Greetings students. In this video, we are going to see how to identify and solve the queuing model MM1 infinity FIFO. This Kendall's notation means what? Single server. This denotes the server. Okay, single server infinite capacity model. This model is called single server infinite capacity model. Let us see how to identify this model from the problem and how to solve the problem. Okay. Let us consider this problem. Customers arrive at a one-man barber shop according to a Poisson process. So, customers arrive at a one-man barber shop. Means what? It's a one-man. So, single server. Here, server is the barber shop. The barber is the server. So one-man barber shop means there is only one server. According to a Poisson process with a mean inter-arrival time of 20 minutes. Customers spend an average of 15 minutes in the barber's chair. That is, service time is 15 minutes. If an hour is used as the unit of time, then these are all the things they have asked to find. First, let us see how to identify the model. So, it is given that it is a one-man barber shop, so it is a single server. So, nothing has been specified about the capacity of the barber shop. Only these many person can come, only these many person can wait. Like this, nothing is being specified about the capacity of this barber shop. Means it's infinite capacity. So it comes under single server infinite capacity model, that is MM1 infinity FIFO model. Okay. Once after identifying the model from the question, we should take the value of lambda and mu. What is lambda? Lambda denotes the arrival rate of arrival, and mu denotes the service rate, the rate at which the service is provided. So from the question, we should get lambda and mu. And one more thing we should know is the model. For this model, that is single server infinite capacity model, these are all the formula we should be thorough with before we do the problem. Okay, so Little's formula is the formula which is common for all the models, which from using this formula, we can get the value of one from the other. What all these denotes for? First, let us know what all these denotes. LS means length of the system. Okay, LQ means length of the queue. How many customers are waiting in the queue? Length of the queue. Okay, WS means waiting time in the system, and WQ means waiting time in the queue. Lambda denotes the arrival rate, mu denotes the service rate. So these are all the notations, common notations we'll use. So once we know any of this WS, WQ, LS, LQ, we'll be able to find the remaining three using this Little's formula. So for all the models, we should be thorough with this formula first. Then, particularly for this single server infinite capacity model, we should be thorough with these 5 basic formulae. What are they? WS, the formula for to find the waiting time in the system, is given as 1 by mu minus lambda. See, these are all exclusively for this single server infinite capacity model I'm talking about. Okay, so WS is 1 by mu minus lambda. And always rho denotes lambda by mu, service rate by arrival by service. Okay, that is denoted as rho. Then PN denotes probability that there are n customers in the system, is given by the formula rho per n into 1 minus rho, where rho is lambda by mu. Probability of n greater than or equal to k, that is probability that the number of customers in the system is greater than or equal to the value k. If it is asked, then it can be calculated by the formula rho per k. And what is the probability that the system is busy or the channel is busy? Is rho. Rho is the probability that the channel is busy. Means 1 minus rho is the probability that the channel is empty, that is idle. So the probability that there are no customers in the system is given as 1 minus rho. So these are all the formulae we'll be using in this single server infinite capacity model. Okay. Okay, coming back to the problem which we are discussing. Let us see what exactly is the arrival rate and service rate, that is mu and lambda. It is given that arrival is according to a Poisson process with mean inter-arrival time of 20 minutes. It is given that arrival follows the Poisson process whose mean is given. Mean of the inter-arrival time. We know that in the Poisson process, the inter-arrival time follows exponential. So because they have given mean inter-arrival time, that is they have given the mean of exponential is given as what? 20 minutes. What is mean of exponential distribution? Is nothing but the reciprocal of the parameter. So mean of exponential is given, means arrival rate lambda is nothing but 1, you have to take the reciprocal. Okay, 1 by 20 per minute. Okay, so arrival rate lambda is given as 1 by 20 per, and customers spend an average of 15 minutes in the barber shop. So here average, that is again mean is given as 15. What is mean of the exponential distribution is nothing but reciprocal of the parameter. So here mean is given as 15 minutes. So service rate, that is mu is again is reciprocal of the parameter, that is 1 by 15 per minute. So these are all the given information. So lambda is 1 by 20 and mu is 1 by 50. This writing lambda mu matters a lot from the question. That is, in the question, they'll give you in two ways. One is directly they'll give you the arrival rate, the rate at which the customers arrive, the rate at which the service is being taken. If they give you rate, means directly you can take the value. Instead, if they give you mean or average, means of the exponential, means we have to take the reciprocal. Okay. So taking lambda mu, we have to concentrate whether we have to take it as such or we have to take the reciprocal. One more thing to remember is lambda mu both will be similar. That is one, if lambda is 1 by 20, mu is also will be like 1 by fraction. Lambda is 20, mu is 1 by 15, like that it won't be there. Lambda and mu, arrival and service rate will be similar. Okay. Okay. So what else is given in the question? If an hour is used as the unit of time, means all the answers, whatever is being asked, we have to convert. We have to give the answer in terms of the hours. Unit time, we have to take in terms of the hour, even though they have given all the parameters lambda and mu in terms of minute. The answer we have to provide in terms of hour. Conversion, we know minute to hour conversion. We'll divide by 60 at last. Okay. Then, what are all the things being asked? What is the probability that a customer need not wait for a haircut? Means when the customer need not wait, when the customer arrives, if nobody is there in the barber shop, nobody is there in the service, then the customer need not wait. When this will happen? Only when the system is idle. Probability that there is no customer in the system. So customer need not wait means we have to find the P naught, probability that there is no customer in the system. Okay. Next question, what is the expected number of customers in the barber shop and in the queue? What is the expected number of customers in the barber shop? Okay. So means what? Length of the system. Okay. How many customers are in the system? Barber shop denotes the system. So LS they are asking, and in the queue means as well as LQ they are asking. Okay, number of customers means length. Okay, next question. How much time can a customer expect to spend in the barber shop? That is expected waiting time in the system. Barber shop denotes the system. So expected waiting time in the system means WS they are asking. Next question. Find the average time that a customer spends in the queue. Okay, average time the customer spends in the queue. So waiting time in the queue, WQ. Next, last subdivision is what is the probability that there will be more than 3 customers in the system. Okay, so probability that there will be more than 3 customers in the system. P of n greater than 3. This is what asked. So, based on the given lambda mu, we have to find all these subdivisions. Let us find it one by one using the formula set which we have. Okay. First, we have identified the model as well as the arrival rate and service rate. Okay, first question is, what is the probability that the customer need not wait for the hand? So, first subdivision, what is the probability that the customer need not wait? That is, the system is empty. What is the formula? It is 1 minus rho. What is rho? Rho is, commonly we'll find rho first. Rho is lambda by mu. What is lambda by mu? Lambda is 1 by 20, mu is 1 by 15. So 1 by 20 divided by 1 by 15. That is 1 by 20, reciprocal is 15. 15 by 20. That is our rho. Okay, we'll use this rho. So we'll take it, find it, and we'll keep it. Wherever we want, we'll use it. Okay. So 1 minus rho, that is 1 minus 15 by 20. That is 5 by 20. What is 5 by 20? 0.25. This is the probability that the arriving customer need not wait. That is the probability that the system is empty, idle. Okay. Next, second subdivision, we have to find what is the expected number of customers in the barber shop as well as in the queue. So whenever we get into the littles formula, that is finding WS, WQ, LS, LQ, all those we have to find, no? That is what asked. LS, LQ, WS, WQ. One by one we have to find. In model 1, already I told it is enough to memorize WS. Remaining we'll get from the littles formula. So whatever is being asked, first we'll find WS. Okay. First, we'll find WS. What is the formula for WS? 1 by mu minus lambda. That is 1 by mu is 1 by 15. Lambda is 1 by 20. Taking 60 as LCM and reciprocating it, it is 60 minutes. Till now, we are just proceeding with minutes. Okay, subdivisions whenever needed, we'll convert it. So, second subdivision, what is the expected number of customers in the queue and in the barber shop? That is LS and LQ is asked. By Little's formula, what is LS? Lambda WS. Okay, lambda is, what is the value of lambda? 1 by 20. WS, just now we have found that is 60 minutes. That is 60 by 20, that is 3. LS denotes the number of customers in the system, that is in the barber shop. So the number of customers in the barber shop is 3. So 3 customers. Okay, next we have to find number of customers in the queue, that is LQ. So again, by Little's formula, what is LQ? LQ is equal to, what is Little's formula? LS. LQ is equal to, LQ is equal to LS minus lambda by mu. Okay, LS just now we have found as 3. Lambda by mu is, what is lambda by mu? That is rho. Lambda by mu, wherever you use lambda by mu, it is rho. Rho we have found it as 15 by 20. So 3 minus 15 by 20. 15 by 20 means what? 3 by 4. So 3 by 4, which is 12 minus 3 by 4. Simplifying this, 2.25. And this is all about customers. So we cannot take it as 2.25, approximately 2 customers. Okay, this is about customers. So it cannot be 2.25. So we approximate it to the whole number, 2 customers. Third subdivision, what is the expected waiting time in the system? That is WS. Already we have found it as 60 minutes. Already they have asked the unit should be hour. So all the answers, subdivisions will convert it to hour. 60 minutes means 60 by 60 hour. That is 1 hour. Next subdivision, average time spent in the queue. That is WQ. By Little's formula, WQ is nothing but WS minus 1 by nu. Now, till now, our mu was in terms of minutes. Okay. So, for calculation and all, we'll be substituting minutes. At last, we'll convert it to hour. Okay. So, WS in terms of minutes is 60 minus 1 by mu. Reciprocal is 15. So, which is 45 minutes. In terms of hours, 45 by 60 hours. We'll simplify this. Okay. So, the average time the customer spends in the queue, we have found. And the last final subdivision is, what is the probability that the number of customers in the system is more than 3. Last subdivision, probability that the number of customers in the system is more than 3. But what is the formula of this model? Number of customers in the system greater than or equal to 3 is the formula. P of n greater than or equal to k is rho power k. Here they have asked P of n greater than 3. So convert it to equality, then only we can use the formula. So greater than 3 can be written as greater than or equal to P of n greater than or equal to 4. Greater than 3 means it's greater than or equal to 4. So concentrate on this. The formula is P of n greater than or equal to k is rho bar k. That is the formula. So here you should have equality, which is missing in the question. So I am rewriting n greater than 3 as n greater than or equal to 4, which is rho bar k is 4 here. What is rho? 15 by 20. Whole power 4. That is 3 by 4, the whole power 4, simplifying 0.3164. This is about probability, so you need not convert it. Okay, so these are all the 5 subdivisions asked. We have found it one by one. So each model, whenever the question is given, identifying the model and finding the arrival and service rate, that is lambda and mu, matters a lot. Then under each model, a set of formula, if you are thorough with, easily we can do the subdivisions asked. I hope you are clear with model 1, that is single server infinite capacity model. Thank you.